Okay, now we're looking at exercise 18.4, the Coursebook 9. The graph shows the line with equations 2x minus 2, x minus 4, y plus x equals 4. Use a graph to solve this pair of equations simultaneously. Simultaneously means you need to see the intersection, where they intersect each other, meaning that you can see this is one of the solution, this is another solution, this is also another solution. The solution means that is the answer for this question here, because we need to solve it. So let's identify our lines first. They must be in this format so that I can actually use the y-intercept to determine the line. So as you can see, the first one has been arranged for you. -2 is a y-intercept, so I can clearly say that this line here is y is equals to 2x minus 2. Why? Because the y-intercept is at -2. And that's it. The next one, the y-intercept is at -4. So look for -4, and then I'll draw a line and label that as y is equals to x minus 4. Very good. Well, naturally, the other line will be y plus x is equals to 4. All right, since we have all the lines already, what we need to do is we need to solve this equation simultaneously. So the first one wants me to use y is equals to 2x minus 2 and y is equals to x minus 4. Y is equals to 2x minus 2 and y equals to x minus 4. I want to find the intersection between these two lines. As you can see, it's here. So since this is the intersection, the solution is the x value. So let's try to find what's the x value. X is equals to -2. Let's do the next one. It says that we need to find the solution for y is equals to 2x minus 2, y plus x equals to 4. Y equals to 2x minus 2, y plus x is equals to 4. The intersection is here. This one. So to find the solution, I just need to go down to find the x value. X is equals to 2. Last one, x minus 4, y plus x equals to 4. This one and this one, intersection will be here. And just highlight it. You don't need to draw dotted lines because it's on top of the line, on top of the point itself, like x equals to 4. So for number 1 and number 2 is the same thing. So the first step that we need to do is we need to identify our lines. +1 is here. So I can say that this line is y is equals to 2x plus 1. Okay. The next one, -2, -2. Last one, +6. +6. There we go. So the first one, they want me to find the solution between this one, 2x plus 1, and half x minus 2. So the solution is here, where they intersect. Intersect means where they meet each other. And then we just draw dotted lines back. Final answer is x is equals to -2. This is the intersection of the two lines. All right. And then the next one here, y is equals to 2x plus 1 and -half x plus 6. So the intersection between this line and this line will be here. Draw dotted line down. X is equals to 2. Last one, -2, +6. -2, +6. This line and this line, you can see the intersection right here. And we find the x value as the solution. X is equals to 8. Right? So let's look at number 3. Draw the lines with this equation, draw all of them on the same grid. So we actually did this already. And then I'm just going to show it to you right here. You can see. So these are the lines that has been drawn. And then you can see that each and every one of them represents one line. So y equals to x minus 3 can actually go to x negative 3. So this is this black color line. This is y is equals to x minus 3. And then the pink one you can actually see is at 7. 7 will be here. So this is the line that is blue in color. Sorry, not the pink one. And then the last one, the pink one, would be this one. Now they asked us to solve it. You can see y is equals to x minus 3, y equals to 7 minus x. So I need to use this one and this one. So this black color line and then this blue color line, the intersection is clear and it is here. So I'm just going to highlight it. This is the solution. And the solution is equals to x is equals to 5. Very good. And then you go to the next one. Y equals to x minus 3 plus 1 plus 1. This line and this line. You can see already the answer is x is equals to 8. Because I just highlighted. Oopsie. See. Highlight it and then just draw down. Next one, y equals to 7 minus x, half x plus 1. 7 minus x, half x plus 1. Yeah. This is the solution. Let's bring it down. X is equals to. And that's it. Now let's go on to question number 4. Use the graph to find approximate solutions of the following pair of simultaneous equations. So they just want an approximate, means that you can round it off. Okay, because you're reading from the graph, you cannot really see it, but you need to find the solution for each and every one of them. So let's look at the first one here. Y is equals to 0.5x minus 5. Negative 5 will be here. This is the line. They even show it to you already. You don't need to do anything. And then with the other line, which is negative 1.5x plus 30, this line right here. So the intersection is here. So we just need to zoom it in and then try to find the approximate solution. I would say it's 12. Next one, negative 5 and 20. Negative 5 and 20. So you can see the intersection is right here. And you just need to draw it down. I would say it's 21.5. Because you see, 20, 21, 22, 23, 24, 5, 6, 7, 8, 9, 30. So this is 21.5. Next one, plus 20, plus 30. So 20 and 30. Oh, I got the first one wrong. This one is x plus 12. The first one, however, is wrong. First one is the other one. This is x plus 12, my bad. Okay, x equals to 12. This one, the first one is 30 and 5. Correct? 30 and 5. Oh, 30 and 5. Yeah. 30 and 5. Yeah. So the first one, the solution would be 10, 11, 12, 13, 14, 15, 16, 17 and a half. Yeah, like that. Let's get number 5. Same thing that has been drawn for you. immediately you should be able to get the solution. So use approximate solution. So once you have drawn it already, you can see this is +4, this is -2. So dotted line down. Answer will be x is equal to 2.2. Let's look at number 6. Look at these two simultaneous equations. Draw a graph, approximate solution. Okay, we've done this already. Means you draw your graph, you should be able to do it as long as you see as the denominator is 2. You try your best to give multiples of 2 instead of just doing 1, 2, 3, 4. You can see I tried to draw a table of it, where you can see x is equal to 0, which is the easiest one, and then x is equal to 2 instead of 1. If I put 1, I'll get stuck in a tricky situation whereby I need to draw a decimal for a coordinate. It's not that it's impossible, it's just that there is a bigger room for error. So instead, I put 2. Okay, when I put 2 inside, it looks like this. When x is equals to 2, y is equals to half 2 minus 3. So y is equals to half times 2 is 1 minus 3. Y is equals to -2. There you go. When I see this, you get this. But what if I put it to 1? I said, oh, I want to do it numerically or in numerical order. So what x is equals to 1 is a little bit trickier. So you can see here. So there's a decimal, which is, well, if you can draw it, good. If you cannot, then try to just make the multiples of the denominator as your x value, like 2, 4, 6, 8, 10. Same goes for the other one, you can see. Put the denominator, as long as the x value is a multiple of the denominators, 2, 4. So if 1/3, then I'll just put 3 as my x value in order to reduce the chances of mistakes. Okay, once you've drawn it, you can actually see that this is +6 here, -3 here. Approximately, it is, well, I would say 3.1, possibly. And then the last one here, write the equation in the form of y equals to mx plus c. Well, you can. It means that make y your subject. For 7a, it just means that make y your subject. Subject means that we want y to be alone and isolated. There you go. That's how you write it out. Okay, then do B. -1/3x. Okay, this one here, you just need to try your best to understand what happened here, because I just want you to know that this one is actually -1x. So when I divide all the equation by 3, -1x divided by 3 is actually, well, -1x/3, which is also equal to -1/3x. It's the same thing. Okay, so same thing here. The 12 remains. I've moved this 3x over to the other side. And then I divide everything by 2. That's how I get y is equal to 6 minus 3/2x. Okay, so here I divide everything by 3. Slightly different. And then use this graph to solve the equation, this one and this one. So you can actually see what they want. Because when you rearrange like that, you can see what is the y-intercept here, -1, this line, and 6, this line. So I actually want intersection of these two lines, which is right here. And I just work my way to my x-axis. X is equals to 6.